Hello, this is just a really quick video, hopefully really quick video on the last little bits of binomial expansion, just in case you need an example or something, like talk through an example just to help you finish off chapter 4 of P4. So we're just going to pick up right where we left off. So we looked at how we deal with a negative or fractional power. Now we need to, but we only looked at examples where we had like 1 plus x inside of the bracket. The constant term was always 1. We need to look at how we deal with something if it's not a 1. So in this example, we've got root 4 plus x, and the other one we've got 2 plus 3x. So we're going to have a quick look at how we would deal with that. Basically, you need to factorize out that constant and make it 1. But just a couple of things to bear in mind when you do that. So hopefully we know that root of 4 plus x is 4 plus x to the power of a half. And then the 4 inside of that bracket is the problem. So what we want to do is factorize it out of that bracket, leaving us as 1 plus a quarter x, or x over 4. And that is all to the power of a half. So the key thing to remember is that when you factorize out whatever the constant term is, you need to remember to raise it to the power. So we've got 4, 1 plus a quarter x is all to the power of a half. Therefore, the 4 becomes 4 to the power of a half, or root 4, which is 2. 1 plus a quarter x to the power of a half. And then you use your binomial expansion to expand that bracket. I would always do the expansion first and then multiply everything by 2. I kind of leave that until the end. If you're really confident, you could try to do it as you go, but the risk of making mistakes is kind of worth taking that little bit longer to write it out, to kind of do the expansion and then multiply by 2. But doing the expansion, we end up with 1 plus a quarter, using the choose formula, we get a half multiplied by a quarter x. Then we have a half times minus a half over 2 factorial multiplied by a quarter x squared, all squared. Remember to square the quarter as well. I didn't write out how many terms we're doing. We'll do the first 4. So we've got 3. The fourth term would be a half times minus a half times minus 3 over 2 all over 3 factorial multiplied by a quarter x cubed. And again, don't forget to multiply the quarter to cube the quarter as well. Okay, and then that could continue for infinity if we wanted it to. That gives us, when we simplify the binomial expansion, that gives us 2 lots of 1 plus a half times a quarter x is an 1/8 x. When we simplify this term, we get minus 1 over 128 x squared. And then when we expand the cubic term, we get 1 over 1024 x cubed. And again, that could continue forever if we wanted it to. Then we multiply in the 2, giving us 2 plus 2 over 8, which is a quarter, so a quarter x, minus 2 over 128, which is 1 over 64 x squared, plus 2 over 1024, which is 1 over 512 x cubed. Don't forget to state when the expansion is valid. So in this case, we've got a quarter x has to be less than 1. Therefore, modulus x has to be less than 4. So again, the only part that's new is kind of dealing with that constant. That's not a 1. We factorize it outside of the bracket, remembering to raise it to the power that we've been given, and then we multiply it back in right at the end. So this one, we've got 1 over 2 plus 3x squared is 2 plus 3x to the power of minus 2. We factorize out that 2, remembering to raise it to the power of negative 2, which would be 1 over 4. So we end up with a quarter, 2 plus 3x to the power of minus 2. And then we do the expansion. So we get, oh, hang on. 1 plus, that was a mistake. Can't remember without ripping the whole bracket. Yeah, 1 plus. I really messed this up, haven't I? Hang on. Let me start again. We're factorizing out the 2, which means we have to actually divide everything by 2 and not just raise it to the power. So I've raised the 2 that I factorized out to the power of minus 2, gives me a quarter. But then I have 1 plus 3 over 2x inside of the bracket. And then we do the expansion. So again, leave the quarter, deal with that at the end. And we get, when we expand it, we get 1 plus minus 2 times 3 over 2x. I am just checking my solution to make sure I'm not making any silly mistakes. Yeah, so we get minus 2 for the choose function part, and we get 3 over 2x. Then we have plus minus 2 times minus 3 over 2 factorial multiplied by 3 over x squared. And then the fourth term would be minus 2 times minus 3 times minus 4 all over 3 factorial multiplied by 3 over 2x cubed. And again, we could continue that if we really wanted to. Once we simplify each of the terms, once we simplify each of the terms, we end up with, we've still got this quarter, we'll deal with that in a minute. We've got 1 minus 3x plus 27 over 4x squared minus 27 over 2x cubed. And again, we could continue that on forever if we really wanted to. Then we multiply the quarter back in. So we get our final expansion is a quarter minus 3/4 x plus 27 over 16x squared minus 27 over 8x cubed. Remember to state when the expansion's valid. So this time, when 3 over 2x is less than 1, the expansion's valid, therefore x has to be less than 2/3. Okay. I need to go back and double check the mark schemes, but from what I remember, they won't necessarily ask you to state when the expansion's valid, but they do expect you to. And there's a mark allocated to it. I need to double check that. Don't quote me on it. But I'm pretty sure that was how the exam questions worked, was that they won't say in the question, like, find the expansion of whatever and state when the expression's valid. I don't think they say that in the question, but they expect you to do it anyway. But I could be mixing that up with something else, with a domain range kind of question. But anyway, I'll check that and get back to you. And we pause there. and then do a second video on partial fractions, just so that they're not too long and you can break it up if you want to. But yeah, that is expanding a plus bx to the power of n. So binomial expansion, where the constant is not 1, and how you deal with that. Hope it helps. Yeah, and thanks for watching if you did.